So ladies and gentlemen, welcome. My name is Armagan Al-Haq. I'm the manager of program development and partnerships. Thank you so much for joining us. And today I would like to introduce our two speakers for today. The first is Nirupa Balendran. She holds the position of Conservation Energy Manager at Newmarket-Tay Power Distribution Incorporated. In her current role, she works with Newmarket's residential, commercial, and industrial customers to identify and implement energy efficiency projects at their facilities. These projects enable better load management at the customer utility levels as well as contribute the achievement of fixed energy conservation targets at the provincial level. She holds a Bachelor's of Science in Chemical Engineering with a minor in Sustainable Energy from the University of Toronto. She is also a certified energy manager and has over 5 years of experience working in the energy sector. This experience ranges from energy consulting to program design, implementation, and delivery of energy conservation initiatives. Our second speaker for today is Ted Wojcinski, if I pronounced it correctly, sir. Ted is a seasoned utility executive with over 37 years of engineering, operations, and management expertise and a proven track record in the electricity distribution utility industry. Ted holds a Bachelor's of Science in Electrical Engineering from the University of Toronto, Management and Administration Certification designation from the Canadian Institute of Management, and a Master's Certificate in Electricity Sector Leadership from the Schulich School of Business. Ted is a licensed professional engineer in the province of Ontario and is a senior member of the IEEE organization. So ladies and gentlemen, please put your hands together for our speakers for today. Thank you.
Thank you, Armagan. It's my sincere pleasure to be here to speak with you all today. A disclaimer before I start my presentation. I don't have a single equation on there, and I know I'm speaking probably to a room full of engineering students. However, a little bit of context. I actually do have an engineering background. As soon as I graduated, I was working in consulting, and I was crunching numbers, figuring out how many kilowatt hours this particular equipment's going to save. But after a couple months, this got a little bit dry for me. So I really had to think back and take a step back and look at the bigger picture. And as corny as it sounds, I really hope this presentation will help you do the same, to really take a step back and whatever research you're doing, see why am I doing this? What am I contributing to see what's really happening in the province, and that'll really motivate you to really keep going with what you're trying to do. So to get things started, so electricity in Ontario, how does it work? I'm not sure how many of you are familiar with the actual structure in Ontario. However, this is just a quick snapshot of what we have today. Ministry of Energy is the big boss, are the government of Ontario. So they make all the rules, and they're really governed by global initiatives. So the Paris Climate Change Agreement. And that really determines what is Ontario's role in that particular area. Similar to that, energy sector has several other commitments that we really have to listen to the Ministry of Energy. So once they set their policies, it's the first time with the clicker, we've got the Ontario Energy Board as well as the Independent Electricity Systems Operator. IESO is a lot easier to say. However, OEB, they're the regulators. So they're the ones setting distribution rates, or how much you and I pay for electricity. So how much a kilowatt hour is going to cost to get from the grid. IESO, they're actually our system operator. So they're the ones really doing the checks and balances to make sure supply meets demand. So they're working day in and day out, making sure whatever the demand for Ontario is, we have enough supply to provide that. And then the last level down here, it's really just a one-way flow of energy in Ontario right now. We have generation, so hydro, nuclear, wind, solar, and natural gas. And this is actually a pretty clean source. So after we phased out coal in 2014, we're actually pretty good with our GHG emissions. We have a really good renewable mix in there as well, but I'll tell you what the challenges are in a couple of slides. Then we go on to transmission. So essentially you have your central power plants, and then we move that energy that we generate to our distributors. So distributors like ourselves, Newmarket-Tay Power, as well as a couple of other municipally owned distributors across Ontario, tap into these transmission lines to get the electricity to the consumer, so you and I. And I've also put there retailers. So we have distributors, but customers have an option to really purchase energy from a distributor, or they can purchase from what we call retailers. So It's a very small amount of folks out there, so you may have heard of direct energy or just energy. And essentially what they do is they convince customers to go into contracts, and you pay a flat rate for electricity for X amount of years. So that's really up to the customer. It's encouraged the customers to do their research if they want to purchase electricity from a distributor or from a retailer. So again, just to stress here, it's all just one-way flow of energy. You have your central generation plants, and they end up at the customers. So Ontario's electricity supply, so just to kind of give you an idea of what generation looks like in Ontario, I alluded to this earlier, our mix is pretty clean right now. So as you see here, this is our capacity. So essentially what our current system, if it was ever capped out, this is what it would look like. So you can see a good mix here with nuclear, probably should use this, nuclear, gas, hydro, wind, biofuel, solar. However, you'll notice that it's interesting to note, generation output, most of it's nuclear. So more than 60% is coming from our nuclear sources, as well as hydro. So even though there's a little bit of an offset in the mix versus what the output is, we'll kind of dive a little deeper into why that is. And that is a clue. It's actually a little bit cheaper to generate using nuclear versus solar and wind. So hopefully this kind of gets your, the wheels turning in your heads as into why that may be. And I'll kind of dive a little deeper into that so you also understand as well. And our installed capacity is about 36.5 gigawatts. So that's pretty big. That's a lot of energy that's available in Ontario. And you may all have heard of OPG. They're actually, they're a provincially owned entity, and they are the ones running those nuclear plants and some of the hydro plants as well. So they're obviously supplying most of our energy. There are also some private sector generators, so the winds and the solars. They're actually in contracts to provide energy, so we have a reliable source in case we need them. So one of the challenges of Ontario, so we're kind of unique in the sense that we have significant seasonal variations right down to a daily variation. So this is just a snapshot I pulled off the ISO website. And you'll see that when we peak really high. But when we don't need energy or demand, we're quite low. So one of the challenges is how do you design a system, an electricity system that's always there, where it can meet our peaks, but also you're not going to waste any extra energy you generate. So I mean, if we create a system that's always operating at this level, you're wasting a lot of that power that you're creating. Power is money to create that extra energy. Similarly, if we're always down here, your lights are going to go out as soon as we start peaking and getting extra demand. So one of the challenges the ISO has is how do we balance the different sources of energy to make sure electricity is always available? So that's one of the things that we have to consider when we're looking at the supply mix. So what is the ISO solution? So what does Ontario do to try and take into account all these challenges that they have to, that they see on a daily basis? So this is actually one day. And as I mentioned, in a day, our demand actually fluctuates quite a bit. So here in the morning, everyone's asleep, so our demand's pretty low. During the daytime, over here, it kind of starts peaking. But it's interesting that our peak is actually around between 5 to 8 p.m. in the evening. So usually, people go home from work, turn on, their ovens, whatever, stoves, everything. All of a sudden, Ontario's peaking, right? But then, so what ISO or what the whole planning of Ontario's electricity system is such that we have what we call baseload generation. So these are our nukes, our nuclear guys, as well as hydro. So these are on 24/7. So your lights are always on. So they're always providing energy to us regardless of what time of day it is. So as you can see, they're fairly consistent throughout the day. And then as soon as we start peaking, we start tapping into natural gas, right? So natural gas is what we call peaker generation. So they're fairly good at ramping up and ramping down without any financial implications. A nuclear power plant, you shut it down, it's going to take a couple of days for it to ramp back up. So you might have some instances where you don't have any power. So we try to keep those guys on all the time, whereas our gas generators will kind of kick in. And then solar and wind and the other renewables, they'll come in on their own, depending on when is the wind blowing, or when is the sun out. So that's what we call variable generation. So we can tap into them. If it's a sunny day, sure. If it's cloudy, solar is not going to do much for us, right? So that's essentially so it's really a game for the ISO. They're looking at their supply, they're looking at their demand, saying, what can I tap into today to make sure our lights stay on today, right? So what happens, so one of the things that I hope struck some of you when you're looking at this is if you have something that's on all the time, what if Ontario's demand is never, it's low, right? We don't need that extra energy. So if you look here, we generated all this stuff here, but we didn't need it, right? So that's money, right? I mean, it's costs to generate energy. So what does Ontario do with that extra energy? Sometimes you have instances where we don't have enough energy. So where do you get that extra from, right? So this is what we call surplus baseload generation when this happens. So as some of you, if you have heard, we have some contracts with our neighboring countries to sell them our energy. So when we have extra energy just kind of sitting there, we say, hey, Mr. Quebec or whatever, would you like to take some of our energy for this cost? The problem with that is it's really cheap because let's say you're trying to get rid of something real bad, you're obviously going to put it at the lowest price possible. Sometimes these are at negative prices too. So that's where, so that's one of the things that we go into, some of the issues with surplus baseload generation, right? So that's one of the challenges we have to kind of see, what can we, because once electricity is generated, the instant it's generated, it disappears. You can't, this is kind of alluding to what I'm going to go into a little bit later, but can we find a way to keep that electricity here and maybe use it a little bit later, right? Because we're going to need it, right? This generation, if we kept it, we could have used it later in the day instead of selling it to somebody. Another challenge is with wind and solar. So as I mentioned, wind and solar, they're on their own accord. Like I can't control when is the wind going to blow. I can't control when is Mr. Sun going to come out and generate energy. So you'll see here the same day, we had our demand go like this, but wind was actually at 95%. Like it was generating all day long, but we didn't really need it. So you see we were low demand here, but wind was like pushing out a lot of energy. We didn't really need it. Same with solar. Solar is pretty useless during peak time here, but it was peaking way in the middle of the day around noon, but we didn't really need it at that time. So a lot of the time, they're really only, their capacity factor, meaning, how much of their energy are we really using, maybe like 30% or lower, right? Because we're not really using them to their full capacity. So same ideas that maybe we could think of, can we generate that and keep it, right? And instead of letting it just go into thin air, can we maybe keep it and use it at a later time? So as I mentioned, SBG being surplus baseload generation, a lot of it gets exported. So this is what we exported last year in gigawatt hours and where it's going. So most of it's going to Michigan. We've got some with New York. So a couple of places we tap into to send this off to, right? So just something to think about. Instead of curtailing, which means it just kind of goes to waste, or exporting it, is there any way for us to keep it and maybe use it a bit later? So these are where our generators are. Again, I stole this from the ISO website. So it's actually a dynamic website, so I do encourage you guys to go and have a look. You can kind of click on these links and see, okay, what is this plant called? How much is the output? But you can see it's all across Ontario. Wind is kind of just congested over here, but hydro and everything is everywhere across Ontario. Transmission, I'll keep this one quick. Hydro One Networks owns all the transmission lines, most of them. And as in this chart here, they essentially, the lines will just connect all these generating facilities to local distribution companies so that they can tap in and get that energy. So these transmission lines, they run at various kilovolts, and so they're really high voltage lines. So when you look at them, you see those huge ones that, the big ones that carry the wires, they're the high voltage lines, so don't touch them. And so they'll take you to your local distribution company, and there they get stepped down in voltage so that they can be delivered to you and I. So distribution, sorry for all the text, but all it essentially says is local distribution companies, they own and they operate the distribution network. So distribution exactly has the name, as the word implies, we distribute energy to customers. Newmarket-Tay Power, we are a distribution company, and each distribution company has its own jurisdiction. So they have a customer base, and they're responsible for making sure those customers get their electricity. So the rates for those electricity, when selling the electricity to our customers, if you recall, I mentioned the OEB, they're the ones who set the electricity rate. So we're responsible for making sure the same rate is applied to all of our customers. The distribution rate, so the rate that we charge our customers for getting the electricity to them, that we put together, but we do have to get OEB's approval in order to do that. So I'll be probably paying the same rate for electricity as you are here in Waterloo, and I'm in Richmond Hill. However, the distribution rate may vary depending on whichever utility you're with, okay? So in Newmarket, so those big transmission lines, they'll take it to a transformer station, and each utility will tap into the transformer station and step down the voltage and use distribution stations to distribute the electricity. So in Newmarket, we have 4 of them. Did I say 4 or 8? 8. So we tap into Hydro One's transformer stations, and then we'll distribute it to our customers. Okay? So this is just a map of where in Newmarket we have our distribution stations. So we have about a couple of them just spread out. So you can see it's a good spread so that we can reach all of our customers in the most economical way possible. Obviously, we don't want to be using this to get someone down there. We would probably tap into this one for that person there, right? And this is just, and I don't expect you guys to be able to see all the utilities, but there's a lot. There's like over 70. So anything that's gray, the only one you can probably see is Hydro One, which is anything that's gray. So they serve anybody that does not have their own local utility, but we're like some dinky little, over here somewhere. So we're very small compared to obviously some of the larger utilities. However, all of our mandates are the same. We get treated the same across the board. So this is just a snapshot of that. So you may have heard of a lot of utilities, merging and acquisitions happening. So that's their method of trying to, deliver electricity in a more cost-effective way. So, if you kind of team up, maybe you can bring down some rates, or maybe you can offer some better services to the customer base, right? So that's utilities. So Newmarket. This is just a snapshot of who we are. So Newmarket-Tay Power. So this is Google Maps. So this is Newmarket, that's Tay. I don't know how many of you noticed we have 2 words in there, Newmarket-Tay. Tay is actually a smaller township that's about an hour north of us, and we do serve them as well. So they're actually, they don't have any transformer stations. They actually tap into one that's owned by Hydro One. So Hydro One, as I mentioned, any of the rural areas, they own the transformation stations and deliver the power. But since these guys are way out there, they kind of tap into Hydro One's transformer station, sorry. Service area, 74 kilometers squared. And we have quite a bit of distribution wires. And just something interesting to note here that I wanted to point out to you guys, rather than going through the random facts. Our class distribution, you'll notice here, residential, 90%. So we're fast growing. Our urbanization rate is pretty quick. Commercial, small, industrial, 1%. So we have a lot of auto manufacturing companies. By a lot, I mean like a handful, but in our world, it's a lot. However, if you notice their energy consumption, you'll note that our industrial guys really do take a lot of energy for their production. So when we're out there trying to, reduce energy or save costs and things like that, sometimes I just talk to the industrial guys and say, we need to really look at your processes, right? Because what can you do to do it a little bit better so we can bring your consumption a little bit lower? Residential, this is probably a good indication of, we have a lot of people, so that's an expected outcome. Industrials, you can kind of play around, offer them energy management services to see, okay, to make that particular part, maybe we can look at it another way to do it, right? So service area, that's us, we're a square. You can probably get across in about 15 minutes. This is Tay as well. So we have 3, so it's Tay, rather than being urbanized kind of area, it's more of like a touristy thing. They have a lot of harbors, so you can sit there and have fish and chips and enjoy. So you don't really have a lot of, industrial, actually I don't even think there's any industrial folks up there, okay? So, leader in innovation. So I know that sounds very salesy, but we really have taken a lot of steps to help, even though we're a small utility, we know what the issues are with the grid, and we can't do a lot, but we can really offer our support to really achieve, look at ways to maybe bring down the peak, for example. If we bring down the peak, you don't need as much generation. Or come up with tactful ways to encourage our customers to reduce their consumption, or maybe use energy more efficiently, right? So I'm just going to go over some of the stuff that we've done in the past and what we're actually doing currently as well, to really show you that, even though it's a small utility, we can really help in a big way. So as I mentioned, energy conservation, demand response. So demand response just meaning, instead of using your electricity when it's peak time, can you maybe shift it to when it's off peak, right? Can you help us out a little? And then we also have a couple of small scale pilots on the go, which Ted will also speak about one of them. He's the project lead for that. So hopefully that'll give you an idea of what we do have in the pipeline to hopefully advise the bigger implementation across Ontario. Energy conservation. So as I mentioned, this comes just from the Ministry of Energy. It's been mandated that we have to save X amount of, I think it was 7 terawatt hours by 2020 and 30 terawatt hours by 2032. So this is just a mandate all across Ontario. All utilities have their targets. So what we did was all of us got together and thought, because you can't just say save 7 terawatt hours to all of Ontario. This target was broken down into different utilities, and each utility has their own target that'll roll up into the full 30, hopefully by 2032. So we also have a GHG emissions target, so that's part of the climate change action plan as well. So we really have to come up with ways to how can we save energy, but also save greenhouse gas emissions. We work very closely with our municipalities, so we help them develop a municipal energy plan. So this was a plan to help them figure out ways to reduce greenhouse gas reductions. As I mentioned, our electricity source is pretty clean already, so we're not really emitting a lot of greenhouse gases, but we can look at explore other ways to bring down greenhouse gas emissions. Similarly, Conservation First framework, this is strictly for electricity conservation, and this speaks to the target that I mentioned that every utility has to reduce their consumption by 2020 and beyond. So Newmarket-Tay, we've actually reduced already 39% of our target, and we have until 2020 to do that, or else we get a little bit of a slap on the wrist if we don't achieve our target. So one of the demand response initiatives I wanted to briefly talk about is called the Industrial Conservation Initiative. What it essentially means is, well, to give you a bit of background, industrial customers, they pay what we call they pay HOEP and global adjustments. HOEP is the hourly Ontario energy price. So the way that's determined is when ISO is trying to meet supply and demand, they do a day-ahead estimate of what the Ontario demand is going to be. So they'll think, okay, tomorrow it's probably going to be like this many megawatts, right? So it's actually an open market, right? The way the system works, and it's going to be a very quick synopsis of what it really is. So all these different generators we talked about, so like, OPG's plants, the wind generators, solar generators, ISO will say, okay, market, here is what I need, how much energy I need. Now you start bidding. So everybody starts putting in bids. Okay, I'll give you, 10 megawatts for X dollars, right? So they start bidding. Then they close the bid. ISO then determines, okay, who's the cheapest, right? So the cheapest, so they'll start kind of stacking it up, okay, until they reach how much they need, and then they'll set the price. So whatever they're paying those contracted guys, that turns out to be the price for electricity. So that's called the HOEP. And then there's also a global adjustment. So this is the piece of electricity that's a little bit of a pain point. So it's another part of the bill that people pay for, additional contracts or like to make up for infrastructure changes, things like that. So it's a little bit of a part of the bill that's going to help out with the additional contracts and commitments the ISO has made, or even the OPA. So I'll kind of go into a little bit more detail on that. But with the Industrial Conservation Initiative, what it does is encourages large consumers to take their, when their usage, if they can, and do it off-peak. So Ontario has top 5 peaks. It's usually in the summertime when we're peaking at most. And what this initiative does is, okay, it talks to the industrial guys and says, if you guys can reduce how much you put towards Ontario's peak, you'll be awarded, as in you pay less for the global adjustment. global adjustment, just so you guys have an idea, it's in the billions, okay? So it's almost like so I would say it's a debt that we have to pay off, right? So what industrial guys, if they use less and have a smaller, what we call peak demand factor, which I'll explain in a second, they can pay less for global adjustment. Okay, so this is the eligibility requirement for it. I won't get into too many details of that, but let me just show you what I mean by global adjustment. It's a very colorful slide, but it's just telling you what that global adjustment is made of. So as I mentioned, in 2017, our global adjustment, we're in the billions. And what is global adjustment made out of? So you'll see here, a lot of it's like our solar contracts, wind contracts. Someone's got to pay it, right? So if you have energy selling at a really low cost, called the HOEP. So let me show you what HOEP looks like. It's like bare minimum, right? You're paying it's like a very small amount you pay for a kilowatt hour, right? So if everyone's paying such a low price, who's going to pay the global adjustment? So that's why it's distributed amongst everybody. You and I, it's all mixed in our rate, so we don't see it. As you become a larger consumer, you see it as a line item. So to motivate them to stop using so much electricity at the peak time, they'll say, okay, fine, we'll give you a break on your global adjustment. Just use less energy during the Ontario peaks, right? So I'm just going to go back. So you can see here, a lot of this stuff, it's all contracts and things like that we need to pay off. If we issue a contract, where are we going to get the funds for it? So it's like we'll share the pain, right? So that's why everybody kind of pays into it. So that's the conservation initiative. And again, I put here, it's kind of like a zero-sum kind of thing. So if HOEP goes down, global adjustment goes up, meaning that the cost of electricity is fairly consistent when you put them together. If HOEP is not going to cover that cost, then global adjustment has to cover it. Believe it or not, global adjustment used to be this teeny tiny thing, right? It was supposed to be a good thing, but then it just grew and grew, and as we entered more contracts and more commitments came out of it, the cost of it just exploded. And all of a sudden, you as a utility or even a consumer, the actual commodity cost of electricity is very little, right? For the actual cost of the kilowatt hour, most of the payment goes towards global adjustment. So that's another thing we have to think about, like, how can we tactfully get rid of this, We don't want to obviously be entering more contracts, because how else will we get rid of that? It'll just continue to grow. So right now, the ones that benefit from it, the large industrial guys saying, if you help us reduce our Ontario peaks, we'll take you off of that global adjustment payment, right? Does that make some sense? Okay, great. So that peak demand factor I told you about, how can the industrial guys reduce their usage? So this was last year's top 5 peak days in Ontario, right? So this is what we used as a province. That was our top 5 peaks. Let's pretend customer A over there. What were they doing during that time? So what was customer A doing on September 7th at 5 o'clock? He was doing something that caused him to use 3.22 megawatts. So he contributed 3.22 megawatts to the peak. So you add them all up, and okay, so I lied. I do have an equation, a PDF. So you calculate their peak demand factor, and this gets multiplied by the global adjustment amount here. So essentially, if they avoid all the peaks, they're going to pay very little global adjustment, and they only ever need to pay for HOEP, right? And HOEP is like if you look there, it's only like 12 cents per kilowatt hour. Like, it's very little, right? So that really motivates a lot of customers, industrial customers, to reduce their peak hours. Their behavior during peak times. So how does this all connect to Newmarket? We didn't have any they're called Class A customers when they enroll for this particular benefit. We didn't have anybody for a long time, and the government of Ontario was really nice, and they reduced the requirements, the eligibility requirements, and last year we signed on 10 of them. So they're all like gung-ho about saving electricity now, and they're always monitoring the Ontario peaks to make sure that maybe during that time I'll turn off all my lights, and these are big plants, so that makes a difference. Or they'll say I'll shut off a couple of my lines because I'll do this maybe tonight instead of right now, right? Because it's really hot outside. It's probably going to be a peak. So in that way, we've really helped. So I'm actually interested to see what it'll look like next year, to see if these guys actually made an impact, right? So I know the impact on all of Ontario has been huge. Like, we've avoided a lot of generation facility installations or things like that, because we were able to shift that peak, right? So it's all about how can you tactfully use energy with what we have without having to build new plants, things like that. So similar to that, here's a fun fact. Newmarket-Tay Power was actually one of the first, if not the first, to deploy TOU, time of use rates. So the rates you guys see with, on peak, off peak, all that. We actually ran a pilot way back in the day when it was about to be introduced to see how successful it is, right? And we, even though we were small, it was only for about 250 residential customers. We ran it and we saw, hey, look, we actually moved about 3% went off peak, right? People were motivated by, I can pay, instead of paying 9.7 cents for my energy, I can actually do 3.4 cents. That's like a third less, right? So we found that it was actually quite successful in installing smart meters. So we used a mascot called Smarty. Installing smart meters, we were really at the forefront with the Ontario Smart Metering Initiative to get these smart meters out. And then finally, the entire province ended up rolling it out. And essentially, this is a form of demand response, right? It's really moving that, the peak times, encouraging people to operate off-peak. So a lot of customers, even I myself, I know I don't want to turn anything on until 7 p.m. because that's when I know it's going to be cheap, right? So that was that. So and this is actually an interesting one that we actually have on the go right now. So just to give you a little bit of background, the long-term energy plan, so this is directly from the Minister of Energy, and it's been put together to see, okay, how can we set goals for Ontario for energy, energy conservation and getting renewables into the grid, things like that. So one of their mandates was, as a province, we have to procure 50 megawatts of energy storage, right? So energy storage is new. I mean, there's a lot of great stuff out there, but here it's pretty new. And we don't know if our system can really take that. And as I mentioned earlier, we're a one-way flow system. So we're used to giving energy, but we're not used to getting it back, right? So what would be required to make sure that we can get back energy from, for example, an energy storage device that's maybe been charging overnight and wants to feed back, right? So we don't know if our grid can take that. So really, what can you do? You just deploy pilots, right? So the IESO, what they did, so this responsibility was given to Mr. IESO and said, okay, here, you figured this out, right? So what they did, they awarded a couple of contracts to energy storage companies or affiliates, and they were asked to reach that 50 megawatt of installations of energy storage units. These are the winners of the energy storage procurement. Now, I've highlighted this here because Amoresco, where it's going to be installed is none other than in Newmarket, right? So we're going to have a battery storage facility that's going to be located in Newmarket territory, and we're helping with the hookup and everything like that. So what are they installing? They're actually installing Tesla power packs. So these power packs look like little refrigerators. I'll show you in a second. They look like this. This is not ours. This is actually an install that you guys can Google it. It actually has happened in California. A lot of utilities are jumping on board to it. We're going to be one of the first in Newmarket. And essentially, they look like refrigerators, and they have, believe it or not, the same batteries you see in the Tesla cars. They're stacked in there. And how we want to be using these guys once they're installed is we're trying to figure out peak shaving, the thing I've been talking about this whole time, maybe store energy when it's really, really cheap. So remember, it was cheap in the morning or overnight. So run those batteries during the nighttime, store the energy. And then when we start peaking, turn on the battery instead of, tapping into Mr. Nuclear Power Plant or something like that, right? So doing that, we'll be able to really levelize Ontario's demand. So it's not always sporadic like that. So ours are actually going to be two 2-megawatt batteries, Tesla power packs. Nothing's been installed yet. We're hoping for mid-May next year, 2018. So you're always welcome to Newmarket to have a look. And they do have a contract term of 10 years to really assess, is our grid able to take this? And if it's successful, we think this will help really drive towards, like a distributed energy system where rather than transporting energy from a central location to all the different customers, why don't we have batteries, or why don't we have local distribution areas where you can generate your energy and just use it on site, right? So another cool thing about battery storage, you can add them to solar panels, right? So those are things being explored right now. Maybe we're a little behind the game, but we really want to test the water first before having like 1 million Tesla batteries installed. So we're hopeful that this will really guide us in that effort. And now I'm going to pass it over to Ted to talk to you about another cool project we have on the go.
Thank you. Bring the mic.
Oh, I think you can use his mic.
If you're comparing.
Good morning, everyone, and thanks, Nirupa. And as Nirupa mentioned, I'm the project lead that's working with Newmarket-Tay Power in this project that involves a number of other organizations. And this involves transit electrification, specifically the utilization of battery buses on major transit routes. Newmarket is the first in Ontario to participate in this bus pilot project as a utility as part of CUTRIC in their Pan-Ontario electric bus demonstration and integration trial. In fact, actually, it's getting into Pan-Canadian because another partner, transit utility in BC, has just joined on, and they'll be installing these buses as well. This specific trial to Newmarket Hydro will add 6 electric buses to 2 transit routes on the York Region Transit line, as well as a single overhead charging station. The buses will be owned by York Region Transit, and Newmarket-Tay Power will own the charging station. And that's an example of a charging station right now in Europe somewhere. And the key players in this game with us are CUTRIC, Canadian Urban Transit Research and Innovation Consortium, and York Region Transit. So in a sense, the 3 of us are all working together on this pilot to make it go. In terms of the fundamentals in the buses, there are 2 different Canadian manufactured bus types will be used and owned by YRT. 4 by New Flyer. They'll have a 200 kilowatt hour battery pack, which is considered a long range bus. And 2 by Nova Bus. They'll have a 76 kilowatt hour battery pack, which is considered a short-range bus. Nova Bus made in the Quebec area, and New Flyer out of Winnipeg. The overhead, as I mentioned, the overhead bus charger will be owned and maintained by Newmarket-Tay Power, and what it will do is provide en route charging ability for the buses. So the buses will be charged, say for example, they'll be in their bus depots overnight. They'll be charged at the depot, so they'll come out with a full battery charge. And as they're going back and forth in the route, they're going to stop by this charger that'll give them a little boost every time they come around the route to basically extend the range of the kilometers that they'll be able to cover with the battery capacity the bus has. And most of the time it'll be 3 to 5 minute charge at most in terms of when they're giving a boost charge. This is an example of one route. This is Davis Drive route in town of Newmarket. Newmarket, not sure everyone familiar with Newmarket, it's north end of Toronto. But basically you've got Yonge Street here, Davis Drive here. The bus will run along from the Newmarket bus terminal to the west of Yonge Street, all the way across Davis Drive to the 404. There's a parking area there. And it just goes back and forth. The total length of the route is about 11.3 odd kilometers. The charger will be located right here at this bus terminal here, and the bus will be back and forth, so when they arrive here, they'd come in and get a boost from the charger on the battery pack. Some of the things here are showing you some of the route profiles in terms of distance, showing elevation issues. So when buses have to climb grades and everything else, you know, that has different demands on batteries. The frequency of stopping and starting, buses will also have a demand on the battery that is different. For example, if you're running flat out, you're going to use less battery capacity than if you're stopping and starting all the time here or so. This is just another example of the route here, showing the specific route it covers. And this is going right through the main area of Newmarket, and in fact through the major South Lake Hospital area here. So there's a major medical health center in this whole area here. And this whole area here is going to be considered a transit hub in terms of growth in this area as well. This is a second route that, sorry, if I can go back here. The buses on this route that will be deployed on this route will be the New Flyer buses with a 200 kilowatt-hour battery pack. Being 11.4 kilometers, it's considered a bit of a longer route. And so they want York Region Transit, which are the bus operators, their main concern is service availability, 90% on-time plus statistics, so they can't afford to have problems with buses that have charge issues or capacity issues, etc. Bristol route, this is another route that's again starting out of the Newmarket bus terminal here where the charging station is located, but it'll follow a more northerly route through neighborhoods. And it's going to be run by 2 Nova buses with the 76 kilowatt-hour battery pack, so essentially a shorter route. And it's about 8 kilometers in total route length here. This is the overhead charge, now for the technical part, this is the overhead charger specifications. So the input voltage is 600, 347, so they're going to get supplied from Newmarket-Tay Power. Will provide a 3-phase pad mount transformer, taking power from the 13,800 volt grid, transforming it down to 600, 347, and then that will feed into the charging substation. The output voltage of the substation will be between 450 to 750 volt DC range. So it's a DC voltage that's coming out of the substation to power up the battery packs. And the power rating is going to be about 450 kilowatt maximum output power to basically be able to put in as much energy as we can in a limited amount of time. Some of the other specs we have: limited harmonic distortion not to exceed 5%. This is an overhead inverted pantograph. So basically what it is the charging station has a mast, and you'll see that shortly, where a pantograph comes down and basically attaches to bus rails on the top of the bus and then start the charging process. In other cases, you may have some cases where the pantograph is actually on the bus, and you'll see this in Europe where the pantograph goes up and then plugs into rails that are on the charging mast. This one is considered, coming down is considered to be a bit more efficient, and it's something that this pilot aims to prove is the efficiency and the application of the overhead inverted pantograph method. And the charging process is going to be based on an op-charge automatic conductive charging interface. Now this is a charging interface that was developed by Volvo and ABB and Siemens and a number of other key players over in Europe. And it's looking at something that is going to probably be the industry standard for this kind of charging process. A lot of these standards for how you're charging buses and that are still actually in development, especially in North America. And again, the connection standard, we also will have other standards like IEC standards and IEEE standards for communication and connection. So there are a number of standards that are involved in the design of this specific charging installation. This is an example, a picture of a charging installation that's actually in Montreal in service right now. And it was at one of a bus loop. And the charging installation is in here. And this area is kind of the interface from the utility area where you've got incoming power in here with switches, metering, outgoing cables to this charging station here. And this is an example of a overhead mast with an overhead pantograph. When the bus comes under here, you can see the pantograph comes down, and what happens is when the bus comes under it, there's communication between the bus and the pantograph through Wi-Fi. And when this thing senses that the bus is in the correct position, the pantograph comes down, touches the rail, and begins the charging process. And that. So there's a bit of training with the bus drivers to get them used to and positioning the bus correctly, and there's a number of specifications and orientation on how the bus has to be. But once it gets done, and you've seen this action, it's a fairly quick process. Bus comes in, comes down, starts the charging process. And this is and again, this is in Montreal. This is at that charging station you saw before. This is the one at that terminal, and this is a second one on that same route in downtown Montreal. This is, again, Newmarket. This is basically the Newmarket bus terminal where we're going to install the charging installation. I apologize for I'm not sure how well you can see everything in there, but the bus terminal is here. So this is Davis Drive, and this is called Eagle Street. This is the actual terminal here, and there's a huge parking lot. So what we're going to do is we're going to install the charging station in this general area here, and the supply transformer will be here. So we're going to take power off the power lines that come down here through underground ducts, through the metering, to this charging station here. And the buses will basically come in, come under here, and you sit for 3 to 5 minutes to charge up. You can see a bus right there. They use it right now for layover as for a few minutes while the drivers at the end of the route are taking their required breaks or whatever. And that's basically where they're in. So this is for us a very convenient installation. We've got a lot of open space. If we try to install something, as you saw in the diagram on the street, it can be somewhat problematical. As it is here, this charging station is outside and this mast is outside. The charging station for this one is in an adjacent building in a parking garage occupying 2 spaces that they're paying rent for. And that was the only place they could find a space for it. So finding space is important, and this one is ideal. And it also is ideal for future expansion of the pilot project in the phase 2 of this area, should we decide to combine storage with this installation or so. So in general, we believe, this pilot will serve as a technology test bed, but it also will provide for economic growth provincially. It'll create environmental and social benefits. What we're going to be doing is taking 6 diesel buses off the road and replacing them with battery buses that are zero emission, essentially. So this pilot will basically provide a basis for development of EV transit infrastructure in Ontario. It'll also help build a profile of the bus manufacturers and also help promote maybe bringing OEM facilities into Ontario as well to help build the chargers and that. Demonstrate the ability to reduce greenhouse gas emissions through the electrification of the bus transit routes. And we're going to be supporting the federal and provincial greenhouse gas targets that way. And it supports the goals of the long-term energy plan and specifically the town of Newmarket's municipal community energy plan. And we're expected to be, this route, just that one route, 55, it's going to reduce greenhouse gas emissions by 60 to 120,000 kilograms of CO2 a year by just taking those 4 buses off the road. So that's just that one route. And the York Region transit target for buses is to be greenhouse gas free by 2051. So in other words, through a fleet replenishment and replacement process, eventually their target is to have a completely green fleet by 2051. Some of the obstacles we've had to acknowledge in this pilot. There's always issues. Nothing is ever doesn't go without issues. Some of us are regulatory limitations on charger ownership. The regulator, the Ontario Energy Bee, we're a monopoly. All utilities are monopolies. We have, as Nirupa mentioned, we have designated service areas. So the regulator, in one sense, has said, chargers can be put in, vehicle chargers can be put in by anyone. It doesn't have to be a utility. And they're thinking of car chargers in that. This is somewhat different. They haven't come across this, so they said, well, okay, we can let you guys can own them if they support the government's conservation and demand management efforts. And this one specifically will, once we get in, especially when we get into the phase 2 as part of the project with storage and that. Charger location, as I mentioned, where you put these things. Some streets are very congested, very difficult. You saw the size of the mass and the stations, very difficult at times to fit them in. Charger familiarity. This is new technology for everyone here in the area, so you have to train people in the various industries from the OEMs to understand how to own, operate, and maintain these equipment. So we're going to have in this pilot project, we'll have a hand-holding period of about a couple of years with the OEMs for the charger, and then after that, Newmarket-Tay Power personnel, with the help of the OEMs, will own and maintain the chargers going forward. Demand charges. When you take an installation, what we're talking about is a 450 kilowatt installation. When you take that much power, your demand charges can be as much as or more than your energy charges. So you can be paying more for just pulling that much power out of the grid at one time. And that's what all the transit agencies are finding throughout North America when they put these pilots, some of these pilots in, that that's a considerable issue that they have to deal with. And again, some of that will be alleviated by the implementation, as Nirupa mentioned, of storage in that as well. Cost. These are expensive units. You know, you're talking about a bus is about $1 million bus. That charger is about $1 million charger, roughly. Limited local support for the charger, parts maintenance. Right now, those are made, the chargers are made in Europe, so they'll be shipped over here. So we have to have agreements with the OEMs to have the associated parts and ability to have personnel and parts available within a specified time period to make sure these things are running. Again, we are supplying, we are essentially going to be the fuel supplier to York Region Transit. They have a service uptime requirement. They need to be there on time, so we have to make sure that from our end, not just the bus is working properly, but also that charger is working properly at all times as well. And that was maintaining on times performance. Okay, long-term, some of the risks, this is new to us, so some of the risks we're taking on with this pilot is we don't know the long-term reliability of the station infrastructure. It's new equipment for us. We're quite familiar with things we work with every day. This is somewhat new, so there's a little bit of a risk there, although we rely on, you know, the OEMs that have built these chargers, and generally there are two OEMs that built these chargers that we'll be using in these pilots in Ontario. One is ABB and the other is Siemens. Post-trial cost of ongoing maintenance and support, you know, how much is that going to cost us? So if those costs tend to rise, then you know, that has an implication on the cost of ownership as well. Changes in the route. Again, we're the fuel supplier to the transit. If they change the route, then that charger there is a stranded asset. So we have to work closely with where these things are going to be. They have to be in key locations where you're not likely to change the transit routes. And commitment of the local agency, continue the utilization on the trial once the trial is completed. So once the trial is completed, we're looking at them to say, okay, you guys should continue to be using these buses. Existing station compatibility with finalized plug-and-play charging systems and future buses. So this, again, comes down to the standards that are being developed right now. So again, part of this pilot is to develop a coherent set of standards and to basically have all the OEMs of the buses and the overhead chargers saying, yes, we're all going to use these same standards so that we're all compatible. In other words, I can use an ABB overhead charger with a Nova bus or a New Flyer bus, and the same thing with a Siemens overhead charger. I will be able to use that with a Nova bus or a New Flyer bus, and there should be no issues of compatibility. And again, access to data. We are assuming will be access to enough electric vehicle and charger data to determine how is this performing. This is a key part of this pilot is, okay, how well is this thing going to perform throughout the trial period? What are the results? And to be able to have that information and to do reports. Some of the other issues that will be alleviated through discussion and standards, and that is ability of the charging station utility communicate with one another seamlessly to support demand management mechanisms or load shifting. In other words, our ability to control that charger as required, perhaps ramp down the power at a certain time that it can provide to the bus. And we have to basically get the charging station providers to demonstrate that they have been, their communication tools have been optimized for our environment. Current and future regulatory decisions affecting ownership and really has a huge impact on us. If the regulator tomorrow comes out and says you guys aren't allowed to own it, then that's a problem for us. Because generally what we're assuming is working with this, we're basically going to own and operate this charger, and it will be embedded. The cost of that unit, our own operate, it will be embedded in our electricity rates, and we have to make a rate of return on that. And an example I'll say of where you can see the future is going on this is California, where the utility regulator and through state legislation has changed their description of what's in the interest of the consumer. And it's interesting is saying as a regulated utility, you can make expenditures as long as they're in the interest of the consumer. And some of the new requirements that they've put in saying, I shouldn't say requirements, but what is considered to be interests of the consumer, things such as greenhouse gas reduction. If you can demonstrate your expenditures reducing greenhouse gas reduction, that's in the interest of the consumer. That's new, and that's California. They tend to lead the way in that regard. And this is, again, a specific infrastructure installation to service transit buses. At this time, we can't use it for other EV or electrical grid purposes, so this is another risk that part of the pilot. So these are all risks that we have considered when we got into the pilot, and this is why we work closely with our partners at York Region Transit and Kutruk in working with this. And that's the end of my part of the presentation. So any questions for myself or Nirupa?
So, questions?
Yes.
So, are you socializing the cost of that charging station with the entire rate base?
That's the intent. That's the only way it's going to work at the moment, unless the other option is the transit agency could own theoretically all the infrastructure, in which case it would be funded through the transit rates. So this is again something that is from the regulatory point of view, it is a bit of a gray area right now. It provides, as you said, considering the reduction of greenhouse gas emissions and that, and with the community at Newmarket Town and Newmarket Community Energy Plan, this is considered to be in the public interest.
And so did York Region Transit not want to own the charging station?
No, they actually preferred the Newmarket-Tay Power to own the charging station and wanted to work with us. It's something new to them. They're basically saying, look, our expertise is in with buses and that, not with the electrical side of the grid.
They weren't just trying to offload the cost on the rate fare?
No, cost is a function. Another utility, that's their position. Another utility, Brampton Transit, they're actually owning the buses and the charging station as well on us. Part of it is Newmarket-Tay Power's, again, leading in the areas of innovation, and we're actually one of the few utilities that are in the game at this point, willing to partner up with the transit agencies to make this work. If you don't have partners in this thing, it's going to be very difficult to get off the ground. So again, this is a pilot. It's a one-of pilot type of thing. And what we're going to get out of this is a lot of data from performance studies and reports and recommendations that hopefully will basically affect policy in the provincial government and in the municipalities, as well as where are we going with this.
So I want to ask a question from you, but it was in your part.
No problem.
So, like, we know that there is this huge difference between the electricity supply and electricity demand in Ontario. Like, electricity supply is way more than that, right? So, do you think, like, Ontario even needs to reduce its electricity use? Because I'm not talking about the peak thing. So, because you have to spend a lot of money on reducing your electricity emission, then save that emission and then pay US to take that electricity from you, right?
Right.
Yeah, is it like, do you think it's like, like general point of view, does it make sense for Ontario to reduce the electricity emission?
It's a good question. So essentially, reducing will help us in the future, right? So these plants that we have right now, eventually they're going to reach end of life. So you come to that point where you think, okay, do we want to, for example, nuclear refurbishment? Do we want to spend all that money to bring those plants online again? Or are we okay with where we are right now with conservation and those initiatives that we take to try and bring down what Ontario needs as its demand? Does that make some sense?
Yeah, but the thing is, like, even in long term, you can't just have solar and wind, right? You should have something like base generation. So
Yeah.
you need
So
Ontario hydro anyways.
absolutely, yeah. So that's why we're hoping that our pilots will kind of change that conversation to, try to encourage like local energy generation. So things like, you said solar or battery storage, because the world is changing, right? People want more power over their power, as funny as that sounds. So people want to generate their own energy. I get inquiries about, can I put a solar panel on my roof, right? And they want to feed back into the system, because it's almost like, look at your Airbnbs and Ubers. They want the power to give and take. So everyone's becoming prosumers, right? So that's where the world is kind of headed. So we're hoping that if we encourage that kind of local energy generation, we'll kind of keep up with that. Because as a utility, our business is in selling energy. All of a sudden, we want everyone wants to sell back to us and make money off of us, right? It's because they just want to use our distribution lines. So that's where we kind of have to be 2 steps ahead to make sure we're prepared for that. So we're doing these pilots and things like that to see, okay, rather than having a central, come from a plant down to the customer, what if the customer has a little bit more power in where they get their power from? right? So yes, sometimes there are some upfront costs and things like that to build that system. And the only way we can really do that is test out different things. So our battery storage pilot hopefully will guide that. Electrification, for example, hopefully will guide that as well. So fingers crossed, we're headed that way.
Can I just add to that?
Absolutely.
And just to add to terms of where are we going, if you look at the provincial and federal targets for greenhouse gas emissions, and for example, one of the provincial targets is 5% of electric vehicles, I believe, by 2051. Okay, they will need supplies of electricity. They will also need demand management and control of how that's done. If we're going to reduce greenhouse gas emission, that not only affects vehicle and transit, also affects the kind of heating that you see in the houses next door. If you may go from gas to electric heat, and that, if you want to extend that thought, where are we going to go? Well, then that's another area that'll likely be explored and saying, okay, if we're going to have more electric heat, you're going to need more sources of energy in that. So in a sense, what we have right now is a honeymoon period, if you want to call it, where we've got that surplus baseload generation, but that's not going to last. And then we have to look at it as well in terms of that mix, you supply mix, our physical plant facilities. They don't last forever, and when you start decommissioning things like nuclear plants or shutting them down even for refurbishment, that takes a big chunk out of the grid that's going to cut back on that surplus as well at a specific time.
So, but there's this argument again that like a country like Canada, because it has a lot of natural gas, so why do you have to spend a lot of money to just put all this renewable in? Because like you don't need it, right? You're energy secure kind of, and natural gas is not as bad as coal, right?
No, it's not. But the only thing with natural gas is the CO2. And if you're into CO2 reduction, as you have in the provincial and federal policy statements, then natural gas, while it is plentiful in that, okay, there's how do we deal with that in another way? How do we eliminate the CO2 impact from that? And one way is using electricity from clean resources as an alternative. That's not going to happen overnight and not at a big scale. And it certainly has to be cost competitive as well at some certain point in time. Or you do something with the natural gas emissions. If you look at, in the U.S. a number of years ago, if you look at FutureGen, I mean, they've got coal coming out their ears in the U.S., so the U.S. DOE had been looking at a plant like FutureGen where they're trying to basically use coal but sequester all the emissions. Nothing comes out of the stack. Mineralize the CO2 and other factors. And it's been a while since I looked at that, but I'm not sure where they got along. But those are things that are looked at saying, yeah, you got these resources, but you also have to look at the big long-term picture is, if greenhouse gas reduction, if that is your target, how are you going to deal with that? Question?
I just was wondering about your demand charges. If you could go into some more detail about how you resolve that. And then just as a corollary to that, if you would have an incentive to take the electric buses off the route on hot days and just run diesel buses to avoid your, if you became an industrial user, to avoid your global adjustment charge.
Oh, okay.
It seems a bit of a perverse incentive in some ways.
Yeah, well, I guess with the diesel buses, or with the battery, but demand charges, okay, basically every general service customer gets charged a demand charge. In other words, what is their impact on the grid? And I don't have a slide to show you, unfortunately, like that, but it can make up a considerable part. And what it is
No, I was more wondering if you avoided the cost or if you really have to pay the demand charge.
right now, the transit agencies, and a lot of them that have some, especially in Europe and in the U.S., that have deployed a bus here or a bus there. In Montreal, in fact, one of the lessons learned when we talked with them was, surprise, we didn't understand the impact of demand charges. And what it is when you go from 0 to 450 kilowatts for a moment, you need that extra capacity, and that capacity has a pretty hefty price. So in our pilot here, let me give you an example hypothetically. Our pilot here, we're going to have a 500 kVA transformer supplying the substation. The substation is going to have 450 kilowatt output. So the bus will come in and may draw power for 5 minutes at, let's say, 450 kilowatt. Your demand charge is based on your 15-minute average of the hour. Okay, so that demand charge, if they draw for 5 minutes, 450 kilowatt just for that hour. The equivalent demand charge, because it's a 15-minute average, will be about 150 kilowatt. If they draw it for 10 minutes, it would be 300 kilowatts. If they draw it for 15 minutes, it would be 450 kilowatts. If they draw it for a half an hour, it would be 450 kilowatts. So it's that narrow window. So when they're coming in and charging shortly, they're having this big spike of power. But you need grid facilities all the way back to the generating stations to supply that. And that's what the cost of demand charges is trying to recover. So one way you try to deal with that is, and this will come into future phases of the pilots that we're working on, is storage. So you saw that, I don't know if I can go back. Oops. Okay, so you saw this station here. So bus comes in, he's going to draw 450 kilowatts, for 5 minutes, say, off that charger. If I put in a storage system in here, say a 2 megawatt battery like Ameresco is doing in another substation, another area, I can trickle charge that storage unit here and then use that to supply the buses. So instead of going 450 kilowatts, maybe 10, 20 kilowatts over an hour, your demand charges would drop considerably. Good news for the buses, for the grid, and everyone else. That is one of the examples that we're going to try to show in the future is the value of storage and how it can reduce and offset that. And that's one reason why this facility is a perfect facility for hopefully implementing that, assuming we're involved. But that's how you do. For the storage, I could trickle charge this, so that the bus, when it comes in, instead of being charged up from the transformer, the storage battery discharges through the charging station into the bus battery, and then the bus goes off, and then I start trickle charging it again. And that's a theory, how it would work. So, and the idea is that eventually York Region's over time goal is no diesel buses by 20. Well, that's to be determined. I mean, I'm not sure. We're not even in that talking stage yet of how that's going to work. But if somebody would own the storage facility, because it would have to interconnect in here. Yeah. Yes.
For the Global Adjustment Program, how well can we predict when those peak hours are coming?
Good question. So that's actually a business of its own. So we have folks, the ISO actually has on their website, they'll kind of put down what the peaks are. They predict what the demand is going to look like for the next couple of hours. And then there are folks out there who offer peak, peak predicting services. So they have their own algorithms where they put in all the numbers and say, I can help you predict your peak, but for this cost. So really, it's doable, but what's an interesting thing, which I hope you guys can think about, is so let's say, you have now like 1,000 industrial customers signed up to avoid the peak. The peak is right now 5 to 8. You have our large consumers all avoiding the peak at the same time. Is that going to be the peak anymore? Nobody knows. So you know what I mean? So if everyone's getting off of that peak that's right there right now, it's a great story. But all of a sudden, predicting that peak is going to become more and more challenging, which is what I'm interested to see. So next year, log on to the ISO website and have a look at what was, next year's peaks. Because if you have all these customers trying to avoid the hottest day, all of a sudden the hottest day is not going to be an indication of Ontario's peak, right? So it is doable, yes, but to some extent. For this particular Ameresco project, it's actually a contract directly with the ISO. So we're providing our utility service in terms of, we'll obviously be providing the power and we'll do all the electrical hookups and checks. However, the ISO will be using that as almost like a demand response technology that they can use whenever, Ontario's peaking, they'll tap Ameresco on the back and say, hey, I need you to use your storage today. So we won't really see too much in terms of control on that particular unit. However, this is a contract between Ameresco and the ISO. But going down the road, I mean, in my role, I get a lot of questions from customers asking, for example, the Industrial Conservation Initiative, they'll ask, can I install a battery storage device at my plant so I can avoid the peak? So that won't affect their day-to-day operation. they'll charge the battery, and when it's peak time, they'll kick on the battery, and all of a sudden, they're not using as much energy, right? So I see it coming into the future. People are kind of taking baby steps to see if it'll work out for them, because no one really knows what the implications are too much. But it is in the pipeline. So that particular one, it's just a direct contract with the IESO. Anything else?
Do you provide any services or either equipment to help industries like factories maximize the electric efficiencies, like power factors and things like that? Do you provide any devices, any other than better rate during peak time?
Right. So we have incentive programs, so which kind of directly connects to their rates. So if they implement an energy efficiency measure, so for example, replace a really old compressor with something new and more efficient, they do get about 10 cents per kilowatt hour that they save. There's also a demand reduction incentive as well. So this is all part of the government's program, part of the Conservation First program. So that's why we're out there knocking on these industrial customers saying, remember I mentioned in Newmarket, about 40-something% is all industrial consumption. So we talk to them, help them out, put together an energy management plan. And when the carrot on the stick is really, we'll give you some money to do this. We'll help you do this, right? So there are some incentives, but with regards to actual technologies, there are tons of folks out there, so we encourage them to really, explore, see if they can find some good contractors or providers of energy efficient systems. And we'll be there to back them up with, here, since you're doing something good, we'll provide you some incentive for that.
I guess we can take one more question.
So for the buses, do you consider, especially when you talk about the challenges and the risks about demand side management when you communicate with the utility? So do you consider the hybrid buses, so in order to contribute to the demand side, so they might order you not to charge or to delay, so they can still use your buses in that way. And my second question is, you say we charge sometimes for each 4, 5, 6 minutes at each loop, right? So does that affect the lifetime of the battery of the vehicle? Like charging many times during the day and discharging and discharging?
So I think your first question was on hybrid vehicles and demand charges.
Yeah, my first question is if you use hybrid vehicles, so and to contribute or to communicate with the utility for the demand side measure. So sometimes they order you at the peak times is good if you are not charging at this time. So you can still use your vehicle, right, without charging.
Okay. And are you talking specifically buses or cars?
No, for the bus.
For I would suspect hybrid vehicle buses, and again, I'm not that familiar with the hybrids, but they would probably charge overnight in their bus depots, I would think, for the most part. And I guess they're gas and battery combined. So I don't think they have any kind of major impact on the daily demand peak that we're likely to see. They have a battery that gets them, and then they also have a gas engine that goes from A to B. And I would think for the most part they use depot charging. They're not involved. They would not be able to charge with this here at all. They're not designed that way. But I would think if they're depot charging and charging at night, that wouldn't have any impact on peak demand, and they would have a number charging one time, probably less than the depots using during the day. And so your second question was on?
In terms of charging at each time.
Charging each time? That shouldn't have an impact. The OEMs, and this is the bus manufacturers and batteries, basically they guarantee, well, this battery will run through various cycles to an 8-year life, let's say. You have an 8-year life and going back and forth, that's expected that they're going to be up and down charging. It won't have a big impact. Certainly every time you charge and discharge a battery, you will have a loss of life. But as in cars, for example, they kind of use the 80-20 rule, I think, in general. Whereas, your car, you charge your battery up, you're using about 80%, or your range that you're seeing is about 80% of what it really can deliver. And so after 7 years of using a car, a battery, you're still getting that same range, because while it's used 20%, let's say, loss of life, it's still got that range that it can deliver. So that would be kind of the same concept you'd see in the bus batteries. You'd have batteries saying, yeah, they're going to have a bit of loss of life. They had some issues with some buses, pure battery buses that didn't have charging with one manufacturer. They had thermal management issues where up in the cold, they couldn't handle the cold and they were getting huge loss of life because of the cold. So they realized that, no, there needs to be some kind of thermal management issues, a bit thermal management capability with the battery systems and stuff. But they're designed to deliver a certain capacity and a certain amount of kilometers over an 8-year life. And there's an expected, yeah, you would have loss of life, but that's built into how the battery is built and maintained. You should not, as a transit user, start to say, I'm seeing a lot less range after 8 years. But after 8 years, they'd probably say replace the pack. And you still have a lot of life left in that battery for other applications, for example.
Last question, there we go.
Has anybody looked at just swapping the battery pack, like when you stop?
Yeah, well,
a whole big battery?
well, car manufacturer actually was one of the first, and that was Renault. Better Place, I don't know if you ever heard Better Place, but they're, partnered with Renault, and they had a great video of battery swapping where you come in and they could actually bring a car in and swap your battery pack out, put a new one in within 5 minutes. Boom, you got a brand new battery. And as one executive for another manufacturer said, how'd you like to have a brand new car? You drive it 30 kilometers, you come in, you get a rusty battery put into it from someone else. It's never quite caught on here for whatever reasons it has. I think the battery capability has grown, as we've seen with the cars that have 60 kilowatt hour battery packs you're now seeing in the Bolt and the Teslas and that, and even higher in some of the higher end Teslas. So you're seeing battery technology is increasing, that you're getting more and more range. So that need to possibly, the business case for swapping it out is probably less. You're seeing a lot of high power chargers on the road systems. You've got apps on your phone that tell you where you can go and charge it up. So you can get, most cars nowadays have high power DC charging capability, so you could actually go and spend 15 minutes and charge up half your battery for for that versus taking something out. The other issue is when you change battery pack, now you'd probably have to reset all your computer's parameters in that to manage it. How do you know what to manage? You don't know the performance of this thing that you swapped in. Unless it's loaded up into your software or so prior to going in. So there were a number of issues, and it's never caught on here yet. It was something that was developed overseas. But that has been thought of.
Perfect. Thank you so much, audience, for joining us. And I would also like to thank Nirupa and Ted on behalf of the audience and University of Waterloo and Waterloo Institute for Sustainable Energy for sharing so much knowledge with us. And thank you so much for your presentation.